Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 10A assignment. Okay, first one we're going to take a look at here is number 5. We left Kuala Lumpur at 11:43 and traveled to Penang, a distance of 350 kilometers. We arrived there at 3:39 p.m. Find our average speed in kmh -1. Now, first thing, kmh to the negative first, what this means is this is just kilometers per hour. So basically this h is going to go underneath there because it's h to the negative first. So that just stands for kilometers per hour. Okay, so what we want to do is we want to set this up as kilometers per hour. Okay, so we know that they traveled 350 kilometers, so we got 350 on the top here. And now we just have to figure out how many hours it took them to drive. They started at 11:43 and then they ended at 3:39. So we want to find how much time has elapsed between those two times there. So one thing I like to do is I just like to look at, like, say if it ever crosses over 12 o'clock noon or 12 midnight, I just like to try to figure out how long it was from 11:43 to noon. So that would be, we need to have, it's 17 minutes from 11:43 to noon. And then from noon to 3:39, how long is that? That's 3 hours, 39 minutes, right? So this is 17 minutes to get to noon and 3 hours, 39 minutes past noon. So then I would just simply add those together. So plus 17 minutes, and that gives us 3 hours. And what's that? 56 minutes. Okay. Now, we don't want 3 hours, 56 minutes. We want to know how many total hours there are. So what we got to do is convert our minutes into hours. So what we want to do with that is take 56, divide it by 60. So we will do 56 divided by 60. Weird. Okay, not times 56 divided by 60. I don't know where that came from. 56 divided by 60 gives us 0.933. So this is going to be 3.9333 hours and 350 kilometers. So we will simply take 350 divided by 3.9 with a bunch of threes on the end there, and we get 89.98, so about 90 kilometers an hour, right? Let's go with 89 instead. I think that's a little bit more accurate. Okay. So about 89 kilometers per hour. Okay. Now we got to turn that into meters per second, right? So we want to end up with meters per second. Okay, so right now we have 89 kilometers per hour. So let's say if we want to get rid of the kilometers, what we got to do is our little stoichiometry that hopefully you learned in chemistry here. To get rid of the kilometers, we got to put kilometers down here. 1 kilometer is equal to, we want to turn it into meters. We got to figure out how many meters in a kilometer. That's where we have King Henry died unexpectedly drinking chocolate milk, right? And this is the units, right? So to go units back to kilometers, 1, 2, 3 spots. So move this 1, 2, 3 spots to the right, and that's 1,000 meters is a kilometer, okay? And then we also want to get rid of the hours. So hours is on, so right now, the kilometers now cancel out and we're left with meters. That's what we want. And now we got to get rid of the hour. So we got to put hours up here, 1 hour, and we want to have seconds. So 1 hour equals how many seconds? 60 seconds in 60 minutes. So 60 times 60 is 3,600. Okay. So then now we take our calculator and take our 89, whoa, not 59, 89 times 1,000, right? Because there's our 89 times 1,000 and divide it by 3,600. Divide by 3,600. And we get that it's 24.7 meters per second. Okay? Okay. Let's look at the next example, next problem number 2. This graph shows the height of a seedling during its first 10 weeks. Is the height changing at a constant rate? Explain your answer. Yeah, it's growing as time. It's a nice straight line. That's what makes it a constant rate. So the graph is a straight line. If it was curving, then it would be changing, or like, zigzaggy, it would be changing at a different rate. Okay. Find the rate of change in height. So really all we want to do is just find two coordinates here. So this is 0 and 10. And then this one out here is 10 and 60. And then we can just find the slope between those two. Right? 0 and 10. And 10, 60. Find the slope. 60 minus 10 over 10 minus 0 gives us 50 over 10, which is 5. Okay. Something else we could have done is just said, hey, look, here's a nice little point right next to it. The rise from here to here, if we make this little triangle right here, this is 10, and this is 2. So we could also take 10 over 2, which also equals 5. Either one of those would work since we have nice little intersection points right there. Okay. Moving on to the next number 2. Chris went hiking in the mountains. His elevation above sea level is shown on this graph. Find Chris's average rate of change in elevation from 1 hour to 2.5 hours. So here's 1 hour, and that coordinate is at 100. And then 2.5 hours is right here at 2.5, and that is what, 250? Okay. So we can again just do slope, 1 and 100, and then 2.5 and 250. 250 minus 100 over 2.5 minus 1. So that's what, 150 over 1.5. So that's going to give us 100. 100, and that is meters per hour. That's the elevation. That's the average rate of change in elevation in the first hour and a half. Every hour they're going up 100 meters. Okay? All right. Next one, number 3, for each function, find the average rate of change in f of x from a to b. So really, it's just going from here to there. So one thing you could do is just draw yourself a nice little triangle here, and this rise right here, that's just 1, and then this run here is 2. So it's up 1 over 2. That's the easy way to do it. Another way to do this is to use the points. This is 1, 2, and this is 3, 3. So we could do 1, 2, 3, 3, 3 minus 2 over 3 minus 1 gives us 1/2 that way too. Okay? All right, last one to look at. Find the average rate of change from A to B. So here's A and here's B. I'm going to rise over run. So I'm going to go down, try to make a straight line. That's not very straight, but you get the idea. And then go over. That's down 1, 2, 3, 4, 5. Right? Because all these boxes here just represent 1, so that's -5, and then it's over 1, 2, 3, 4. So it should be -5 over 4. Or you can do it with coordinates. A is at -2, 4. B is at 2, -1. So we could do -2, 4, and 2, -1. -1 minus 4 over 2 minus -2 turns into -5. Not 2, but over 4, which is the same exact thing that we got there. Okay? All right. That's all we have for problems from 10A. If you have any further questions on this, please feel free to ask. Thanks.